Good afternoon to all of you. This is Dr. P. Ravindra Kumar, Professor, Department of Mechanical Engineering, Lecturer at Baladi College of Engineering. So today, this is my 26th video lecture. This is my 26th video lecture. So from the lectures 21 to 25, I have discussed the second law of thermodynamics. So mostly the second law of thermodynamics, Kelvin, Planck and Clausius statements are discussed, and the basic fundamentals are also discussed in the second law of thermodynamics. But in that slides, 20 to 21 to 25 slides, I have applied the second law of thermodynamics to the cycles and cyclic devices. So that means a heat engine is operating between a source and the sink. What is its efficiency? That is a cyclic heat engine. Refrigerator. If a system is operating between the source and the sink, then it is also the cyclic device. So like that, we have discussed the refrigerator, heat pump. So the cyclic means a reversible process. That means where the properties are going to restore to the initial state conditions. Next, after then, now we need to apply the second law of thermodynamics to the various process. So on this context, the entropy concept is needs to be discussed. So from the first law of thermodynamics, it gives the basis for the energy conservation. That is nothing but internal energy is a property of a system. So that energy is nothing but the conserved energy, law of conservation of energy. Whereas the second law of thermodynamics, the definition is going to lead to the entropy. This is entropy is also a property, but it is a non-conserved property. But it is a non-conserved property. So these are the things we have discussed in the earlier cases from the second law of thermodynamics. Now, before going to enter into the entropy, the Clausius inequality is the basic foundation stone for the entropy, which forms the basis for the definition of the entropy. And this continues to increase the principle of entropy. So after listening this particular content, student is expected to learn, understands the entropy and its principles and its applications. How the entropy can be defined, and finally what is the meaning of the entropy. So entropy is nothing but it is the basis for, it is the basis which came from second law of thermodynamics. So entropy is a property of a system, that it is an extensive property. When a property talks about onto this side, internal energy is a property, enthalpy property, entropy is also a property. So on this connection, there is, we can call it as a specific internal energy, specific enthalpy, specific entropy. So this also should not, a student should not forget this particular difference between the property and specific property. That is entropy and specific entropy, enthalpy and specific enthalpy, internal energy and specific internal energy. So before going to define this particular thing, how it is defined. So The entropy is nothing but it is a function of a quantity of heat which shows the possibility of conversion of heat into work. Actually, if you observe that entropy means it is nothing but a transformation. Entropy means it is the transformation. So transformation here, what is that? Entropy, it is a function of a quantity of heat which shows the possibility of conversion of a low grade heat into high grade heat. So on this context, if you observe some of the things connected to this one, so then if a heat is added to a system, then entropy of a system increases. If the heat is rejected or heat removed from the system, entropy of a system decreases. But how much? When you add the amount of heat to a system, the entropy of the system increases. When the heat rejected by the system, entropy of the system decreases. But how much? So the increase in entropy is small. Increase in entropy is small when heat is added at high temperature. Increase in entropy is small when heat is added at high temperature, and is greater when heat addition is made at lower temperature. Thus, for maximum entropy, there is a minimum availability. There is minimum availability for conversion into work. And for minimum entropy, maximum availability for conversion into work. So that is nothing but the tropy, that is entropy, transformation. Transforming the low grade energy into high grade energy. So that is what this entropy is going to discuss. So this is one way of defining the entropy. Entropy you can also define in such a way that it may be defined as, so in other words, it may be defined as it is the property of a substance. It is the property of a substance which remains constant when the substance is expanded or compressed adiabatically in a cylinder. So adiabatically means heat transfer is 0. That means we all know that dq is equal to Tds. So ds is nothing but equal to dq by T. ds is nothing but equal to dq by T. So it is defined as a thermal property of a substance which remains constant. That means entropy remains constant in a reversible adiabatic process. Entropy remains constant in a reversible adiabatic process, or you can call it as an isentropic process. So it is a thermal property of a substance which remains constant when the substance is expanded or compressed adiabatically in a cylinder. So this is the expansion, this is the compression process in a adiabatically in a cylinder. So this is also one way you can define the entropy. So it may be noted that all heat is not equally valuable for converting into heat. There are the different varieties of a quality of a heat is there. Varieties of a heat. So heat that is supplied to a substance, heat that is supplied to a substance at high temperature has the greater possibility of conversion into work than the heat supplied to a substance at lower temperature. To a lower temperature, right? So that is the basic definition or the basic understanding of the entropy. Now, everyone has to make a question onto that one. What is meant by entropy? Why we have to study the entropy? What is the distinction between the energy and entropy? Energy is nothing but the conserved property, but entropy is nothing but the non-conserved property. Energy connected to the first law of a thermodynamics. Entropy connected to the second law of a thermodynamics. So then, what is the entropy? Entropy is nothing but the amount of energy that is not available for work during a certain process. Just before now, we have discussed that the second law of thermodynamics, when you apply it for the process, entropy is going to come into the picture. So the amount of energy that is not available for work, during a certain process, so that is nothing but entropy. There are various ways are there, understanding the entropy in various ways. So there is no standard format, or there is no standard thing connected to this one. The physical understanding of the entropy is very much important. So the amount of energy that is not available for work during a certain process, that is nothing but the entropy. So it is nothing but it is a measure of molecular disorder present in the system. It is a measure of molecular disorder or molecular randomness present in the system. Measurement of disorderness of the molecules present in the system. That is nothing but the entropy. So it is a measure of disorganization or degradation in the universe. So there is a orderly form of energy is there, disorderly form of the energy is there. Organization of the energy, disorganization of the energy. Quality point of view, energy quality point of view, whether it is conserved or whether it is the quality is degraded. So measure of disorganization or degradation in the universe that reduces the available energy or the tendency of available energy to dwindle. Example, chaos, opposite of the order. That is chaos, random nature of the molecules present in the system. So the state of the disorder in a thermodynamic system, it is nothing but it is a state of measure of the disorder in a thermodynamic system. That is nothing but the entropy. The more the energy, the higher the entropy. The more the energy, the higher the entropy. So it is a measure of dispersal or degradation of the energy. It is a measure of dispersal or degradation of the energy. Or in another words, that it is a measure of disorder or randomness in a closed system. Say, for example, if you take the entropy of an unburned piece of a wood, so that is the system and its surroundings. Everything external to the wood is nothing but the surroundings. System plus surroundings is nothing but the universe. So, for example, the entropy of an unburned piece of a wood and its surrounding is lower than the entropy of the burnt wood, that is ashes, and the warmed surroundings due to the burning that piece of the wood. So that means the entropy of the wood is less than the burnt wood. So it is nothing but the entropy is a scientific measure of disorder in the system. Entropy is nothing but it is a one kind of a scientific measurement of disorder in the system. The greater the disorder, the greater the entropy. The greater the disorder, the greater the entropy. So it is nothing but a thermodynamic property. Entropy is nothing but it is a thermodynamic property, that is an extensive property. So it is a measure of the amount of energy in a physical system. It is a measure of amount of energy in a physical system that cannot be used to do the work. So it is a measure of disorder present in the system. So the SI unit of entropy is nothing but joule per Kelvin, which is the same unit as the heat capacity. If it is a specific entropy, then joule per kg Kelvin. So the units joule per Kelvin, it is also having the same units as heat capacity. So entropy, it is defined as a measure of unusable energy within a closed or isolated system. Measure of unusable. So that means